Humans are programmed to love stories. We want a beginning, a middle, and an end. We want a captivating plot with a twist. We want characters that we can love, hate, laugh at, and relate to. We see these things in pretty much every form of entertainment. In movies, TV shows, books, and even video games. They all capitalize on the human desire for a good story. Now before Fallout or Skyrim or World of Warcraft, there are these text-based adventure games. These games are exactly the same as the games you play today on your Xbox, except they involved a tiny bit more imagination. Well, actually a lot more imagination. But the basic idea is the same. You play as a hero, trying to complete a quest by picking up loot, talking to other people, and solving puzzles. Most of these games involve villains, sidekicks, heroes, villagers, townspeople, henchmen, comic relief, things like that. What do all these objects have in common? They're characters. Sometimes objects are all related by a single trait like this. When this happens, we can create what's called an interface to connect them together. By the end of this video, you will be able to understand the definition of an interface and be able to explain what it's used for, understand the parts of the comparable interface and why it exists, and you will create your own class that implements an interface. Let's get started by talking about what an interface is. An interface is a type of class that cannot be instantiated. That means it cannot be made into objects. Unlike the student class that we made in Chapter 4, where we could make individual students, an interface can't be made into actual objects. An interface connects several objects together using a common thread. For example, a hero, a villain, and a sidekick are all objects in a game. They will probably have some things in common, like a health and energy level, or an inventory. Since they will have so many traits in common, it will be useful to have a character interface to connect them. The actual interface is pretty basic. It's just a collection of abstract methods. An abstract method is a method that has no body, just a header. After we write the header, instead of writing out a body, we put a semicolon and move on to the next method. Here's an example of an abstract method. It's weird, right? There's nothing there. That brings us to the first analogy that many teachers use to explain interfaces. Interfaces are like contracts. Anything in the interface must appear in the classes that implement it. If the character interface has a getHealthLevel method, there must be a getHealthLevel method in the hero, the villain, and the sidekick classes. By implementing the interface, a class guarantees that it will have all the methods from the interface. That's actually a vocab word we should mention now. Implement is the reserved word that we use for interfaces. Here's an example. Here we have the hero class that implements character. So normally we would just write public class hero and start creating our class. If your class is going to implement an interface, you need to add implements and then the name of the interface in your first line of code. You'll understand interfaces more once you look at one. So now, open the character interface and the hero class from Moodle and fill out your guided notes as you look through the code. Pause the video now to fill out your notes, then hit play to check your answers. Our first question is how many instance variables are there in the hero class? You can see here that we have name, stamina, strength, current room, is dead, and total heroes. So that's a total of 6 instance variables. How many of these methods are static? We can see that only one has the static reserved word, so only one variable is static. The visibility modifier in all of the instance variables is private. Remember that visibility modifiers are public or private. There are others that we haven't learned about. Those are the only 2 you need to know. Next, how many constructors are there? If we scroll down, we will see that there is only one constructor. There's no default, so your answer to that question should just be 1. The next question is, what does stamina always start at? If we look here, the user doesn't put in a stamina level. Every time you make a new hero, stamina gets set to 8. The next question is, are there any methods in Hero that aren't in character? So here's character. As you can see, these are all abstract methods. There's no body. If we look back in Hero, getName and setName, those are both in character. We've got add stamina, decrease stamina, and get stamina. Those were all in character. Add strength, decrease strength, and get strength were all in character. Make sure here. Set current room and get current room were both there. Is dead and set dead were both there. Here's a method that was not in character. So let's just double check to see if there's a num heroes in character. And there is not. So it is possible to have some methods that aren't in the interface. Alright, and then the last question asks us to comment out the getName method in Hero and see what happens. So if we highlight all of this, we'll do edit, comment lines, and I'll compile it. Alright, the error that we get says error, Hero is not abstract and does not override abstract method getName. This is the important part of the error. Does not override abstract method getName. Remember, the interface is like a contract. If we said that Hero was implementing character, that was our guarantee that it would have every abstract method from character. And since now we don't have getName, we have a problem with our compiler. Now, certain methods in the character interface are probably going to be the same for every class that implements character. Like getName, for example. That will probably be the same for heroes, villains, sidekicks, and any other character in a game. But what about add stamina, or add strength? It's possible that these methods could be different for heroes, or villains, or sidekicks. This is why some people don't like the contract analogy for interfaces. Yes, every class that implements the interface has to have the methods from the interface, but they don't have to be identical. Here's an analogy that some people like better. The toy blocks analogy. This is a toy that lots of kids played with when they were little. There's holes that are different shapes and blocks that can fit through those holes if they're the correct shape. The blocks can be different colors or textures. They can be made out of wood or plastic or cloth or other materials, and they can have different lengths. But ultimately, they have to be the same shape as the hole, otherwise they won't fit through. The interface is like the base of this game. It sets some ground rules like you must have a getName method and you must have a name variable, but it doesn't say how those things have to be created or used. A class that implements the interface is like the block. It must have the required methods, but it can implement them in any way that makes sense for the class. In other words, a hero object has to have a getStamina method, but it can implement it differently than a villain or a sidekick might implement it.